Having been assigned this project in the midst of the NBA playoffs, we decided to explore some NBA statistics and trends. Specifically, we wanted to explore whether or not there was some kind of underlying statistics that determine how long a player is in the NBA for. We obtained all of our data sets from basketballreference.com. The observational units we used were all players selected in the NBA from 1989 and onward. The explanatory variables we chose were the number that a given player was selected in the draft, ranging from 1 to 58, the primary position the player played, either a guard, forward, or center, the player's height in inches, their career points per game, career field goal percentage, and number of win shares that the player recorded throughout their career, which is a complicated statistic that accounts for the number of wins that a player contributes to their team. According to Jump Output, after fitting our model with all of these explanatory variables, pick number, height, and points per game are not useful predictors after adjusting for field goal percentage and win shares. This is because they have insignificant p-values of 0.89, 0.20, and 0.39 respectively. We also have relatively low VIF factors, which is good to see because it indicates that there's not a lot of multicollinearity in the full model if we were to use it. We wanted to take a look at an interaction model as well. Since win shares had the highest R-squared value, we used it as our quantitative explanatory variable and crossed it with whether or not the player was an all-star. From the interaction scatter plot, we can see there's an interaction with win shares and whether or not the player was an all-star. If we were to look at the scatter plot without the interaction distinction, it would appear as though fitting a quadratic model to win shares would be necessary. However, after making the distinction between all-star and non-all-star, we can see that an interaction term suits the model. This is because there are distinct differences in the slopes between all-star and non-all-star. On average, all-star players played 4 to 5 more seasons than their non-all-star counterparts after adjusting for win shares and our interaction term. From this, we derived 2 separate equations. For all-stars, we derived years in the NBA hat is equal to 11.6 plus 0.04296636 times win shares. For non-all-stars, years in the NBA hat is equal to 6.941 plus 0.268675 times win shares. From these equations, we can see that the number of win shares for a non-all-star has a much larger effect on his years in the NBA compared to an all-star. We can also confirm that this is statistically significant from the near zero p-value on the interaction term. The most interesting interpretation of why this is the case is that players who have been all-stars have developed a reputation, which we can't quantify into any explanatory variable. Having a reputation for being a good player can lead to bad seasons being overlooked as just a bad season and not a decline in the player's actual ability, which may be the case for non-all-star players. For example, Kobe Bryant had a few very ineffective, injury-plagued seasons at the end of his career, yet was never cut. If a non-all-star player had had poor seasons like this in their late 30s, they would have almost certainly been cut by their teams. Thank you. Go Warriors.
Playing in isolation behind the talents of LeBron James and the incredible finishing abilities of Kyrie Irving versus the Golden State Warriors.